Waiting.
Where is the bus? The bus is late. Waiting for the bus in the rain. In the rain when the bus comes. Where the bus at? Got my bus packed.
Waiting. 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 This is a shout out to Alex. Thanks for the song. And Imani, I got yours. You're on my next video. Okay, so waiting. You don't have to wait any longer, because what we're talking about right now are describing our quantitative data with numbers. So now we're on section 1.3, and I'm at the bottom of your notes, page 11. So let's talk about something that you guys already know. Okay, what is the mean? The mean is nothing but the sum of a bunch of numbers and dividing by the number or quantity of numbers. Okay, so if I have like a 3 plus 4 plus 5 plus 6, and then I'm going to divide that by, how many digits did I say? 4. And that will give you your mean. And of course, the mean is another word for average. Okay, please recognize the symbol that we're going to be using for mean. Median, we already know that that's the middle number when the numbers have been placed in order. Now, here, when it comes to data, I'm going to talk to you about this, and then in a few minutes, I'm going to show it to you on a later problem. But the idea of resistant. As we look at the idea of resistant measure, resistant means it is not affected. Not affected by extreme values. So when I'm talking about the extreme values that we're used to, we're talking about outliers. So a resistant measure is not affected by, and yeah, I'll refer to the outliers right here. But the reason I have it here is because here, the mean are not resisted. That means it is affected by that outlier. So if I give you the numbers 1, 2, 3, 4, 5, and I ask you to find the average, which is equal to 3, and then after that I say to you, oh, I didn't mean to make it 5, I meant to make it 15. Well, now my average is going to change. And now my new mean, when I have, like I said, the 1, the 2, the 3, the 4, and the 15, my new mean is going to be 5. You can put it in the calculator and check it out. Now, as I talk about the idea of resistant, I continue talking about it. Medians are resistant to outliers. So medians are not affected. Now I'm going to look at these same numbers, and I'm going to write them a little better because this is really kind of sloppy. So if I go 1, 2, 3, 4, 5, our median is equal to 3, right? But now what if I change this? I go 1, 2, 3, 4, 15. That is still the median. So that's when I'm saying the medians, put an S here, are not resistant to outliers, because that 15 is much bigger than that 5. So I'm going to say that looks like it's a potential outlier. Next, as we're talking about quantitative data, it can be represented by the histograms that we spoke of before, but it can also be represented by what you see here, box whisker plots. And with these box whisker plots, here is symmetric if it looks like this, in which, remember, where our mean is approximately the same as our median. This line right here represents the median, and this dot right there represents our mean. Okay, now what about if it's right skewed? If it's right skewed, remember the predominant information's on the left, so I've got the open mouth towards where the data is. And here again, here is your median, here is your mean, and you can see your mean is greater than your median. And if I have it skewed to the left, You can see here the big mouth is going into the direction whereas the majority of the data is, which is on the right side, which makes it skewed left or left skewed. In which here the line is your median, and that dot, just like I said right there, represents your mean. So we're going to see how this is utilized in a few minutes in the problems that we're going to do today, and of course some other problems in the far future, or in the near future, I should say. Now here, the thing is this, as I'm looking at my data, both of these right here, whether it's the mean or the median, are called average. And as I look at those as average, which one do we use? Well, the bottom line is this. If you have outliers, you use the median. It's the best. And you saw why on that last example when I used the numbers 1, 2, 3, 4, and when I changed that 5 to a 15, that outlier did not affect that median at all. But if it was a mean, meaning X bar, no bueno, no good. So the next thing I want to talk about is the idea of measure of spread. And we've talked about this in class, but we've talked about it when it's a histogram. We've talked about it when it's a stem plot, maybe even a dot plot, but I want to talk about it when it pertains to a box plot. So let's look at our range. Our range is our high minus your low, whatever that value is, or you can say high to low, meaning if I give you the numbers 1 and then you have numbers here and the highest one is 6. My range would be 16 minus 1, which can be considered a 15, or I can say my range is represented from the numbers 1 to 16. So it can be represented by subtraction or based on this. When it comes to the box plot, it's the max minus the min, okay? So this one, the first two I gave you were pretty generic and consistent with what we've done before. But when it comes to the box plot, we have a max and a min value. We can subtract them. That'll give us the range. Or like I did before, it could be looking at the min value and looking at in relationship to the max value. Next are quartiles. As we look at the idea of our quartile, our Q1 and our Q3, I think of a quartile as a quarter. And as I look at a quarter, here Q1, which is quartile 1, is the same as the 25th percentile. Now you guys are juniors and seniors, so you know what a percentile is. The majority of you are the top 10%, which means you are at the 90th percentile. So let me show you what I'm talking about. Here, if I've got from 0 to 100, and I'm talking about as a percentage. Here, this is the top 10%, and I'll put the word top. Well, if that's the case, that means right from here to here is the 90th. So this would be, let's look at our notation, P90, which would give us the 90th percentile. And percentiles run just like you see, like a number line from 0 to that point right there, there's 90. And from here to here, that's just a leftover 10%. Again, you guys are the top 10% of your classes. Now I'm going to look over at this. My third quartile. Third quartile is 3/4. As I look at 3/4, that is equivalent to the 75th percentile, because 3/4 is worth 75%. As I continue on, the next term that I want to refer to is the interquartile range. Interquartile range is short for IQR, and the IQR is Q3 minus Q1. Now, I haven't shown you what this looks like on a box plot, which I'm going to show you in a minute. Just wanted to knock these out. But this is a good time to do it now. So as I draw this box plot here is your minimum value. Then here's your max value. Here is your Q1. Here's your Q3. And wait for it, your median. Yes, you might have heard of it as Q2, but nobody in statistics refers to it as that. We want to know our median. So these values are what gives you your quartile 1, median, quartile 3, your minimum and your maximum. And I want to jump down to this problem right here. I'm going to jump down to this. And what I've just given you is the 5-number summary. Now, let's back up to the outlier. As we look at the outliers, how do I, remember how I've said to you before, outliers, there's a formula. And now we're going to utilize that formula. Because if we have raw data, we can determine the outlier. So let me back up right here. Okay? So in order to determine if something's an outlier, there's 2 ways to do it. First of all, if we use what's called a modified box plot, which I will show you in the calculator either today or tomorrow or a little later. And then the other way of determining it is looking at your Q1 minus your 1.5 times the IQR. That gives you your low end. Your high end outlier is your Q3 plus your 1.5 times your IQR. So let me show you a quick example. Okay, now in your calculator, let me clear out of this. Here's the quit. Okay, clear to get rid of everything that's on your desktop. Now I'm going to go to Stat, and then I'm going to go to Edit. Now I have something in my L1, and I want to keep it there. And let's say there's other data in your L2. So what you do is you can either keep pressing the delete key, to get rid of it that way. And that's a lot if you have like 20 pieces of data in there. Or as I put more stuff in there, it's going to give me an error. Yeah, I know. Let me clear it. As I put more data in there, back in there again so you can see. The second way to clear is to go up. Notice up right on top of there where you see your L2 is highlighted, and I'm going to press clear. Do not press delete. I'm going to press clear, and then I'm going to drop it down, and notice that it deletes everything. So you might run a rewind, put some more data in there. Wrong. Here. Okay, so what did I do? Go up to L2, and where you see L2 highlighted, press clear, and then, oh, it's not even showing. Oh, Okay, so let me do that again. Go up to where it says L2, press clear, and then drop it down with this arrow right here, and you notice it deletes. Now, I'm just going to put in numbers 1, 2, 3. You can see how I'm entering them. Let me try to expand out. 1, 2, 3, 4, and then 55. Now we know that those are outliers. Let me turn off this light. Better. Okay, now we know that those are outliers. That 55 is an outlier. Now let me show you something else that we have not done before. Okay, I'm going to show you how to do a box plot in your calculator. We do not do it by hand when we have all the list of raw data. So look up here. I'm going to press second and then plot. Again, second and then stat plot. Now, I'm going to click onto this first one just because I want to. I'm going to press right here, enter, again, down here. And as I press enter, notice what happens. It's highlighted now on the on button. And I need to stop holding this, my arm's in the way. And then as I look at this, now I am going to go over to these. Now notice I've got a histogram. This is a dot plot. This is a line plot. There's a histogram. And I'm going to this first box plot. There's two of them. This is a regular box plot right here. The first one, though, is a modified. I want to go to my modified. And the reason I want to go to my modified is because I want the computer, or the calculator, excuse me, to show me I've got an outlier. And then I can confirm it with the math. Now, my data was in my L2, the data that I want to pay attention to. So please notice above every number here, you've got an L1, L2. So as I try to do this, here I'm gonna press second L2. And you see how that changed? I don't touch the frequency. You can change those if you want to play with things. Then what I'm going to do now is I am going to go to Zoom. Okay, I press that button right there, Zoom. I'm going to go down to Stat. I'm keep pressing my arrow till I get there. And it gives me my box plot. Now, I cannot believe that that thing was not an outlier. There is no way. I need to go back and look at my data. So here, I'm going to press Stat, Edit. That number 55 is there. I'm going to go back and now look at my drawings. So here I go second. Well, I'm going to quit out of this. Second quit. Wrong. Okay, I just want to quit out of that. Now I'm going to press, I want my stat plot again. So second plot. And I just can't believe that that thing was not an outlier. There's no way. You know what? We need to confirm this with using our outlier formula. But you can see how this looks. Now, I don't think I made an error, but let's check it out. Let's look at the outlier formula. I'm going to look at the high-end outlier. So this is Q3 plus 1.5 times the interquartile range. And this was the formula that was given to you. Where is it? Where is it? Where is it? Right there. So my Q3, my numbers were 1, 2, 3, 4. Let me write them down. I'm going to pause for a minute and let you write them down. Now, in order for us to find the interquartile range, I need Q1 and Q3. And yes, we can find Q1 and Q3 knowing that Q1 is, well, finding that that's the median, and Q1 is between there, and Q3 is between there. Okay, but there's also another thing. So let's make note of this. Find your stats key. Right there, you see where my finger is? So now I'm going to quit out of it. I want to go to Stat, go over to Calc, and you see this right here, first vars. First vars is your best friend ever. Okay, so I'm going to click on here. Now, when I see this, I have my L1, but my data is in my L2, so what did I say to do before? I go down, and then I press that button right there. So I press second, and then L2, and it changed, and then I go down and I calculate. Now, you notice you got a bunch of information here that you don't know what it is yet. Give it time. But here, let's all check it out. My 5-number summary. You can see there's your min, there's your Q1, there's your median, there's your Q3, and there is your maximum. So now let's put this in our formula. So here our Q3 is 29.5 plus 1.5 times the interquartile range. Remember, our interquartile range is Q3 minus Q1. And that's going to be 29 minus 5 no, excuse me, 29.5 minus, where'd it go, 1.5. And you know that's 1.5 times 28. So you go ahead and finish the math up. Okay, so this is what I have when I did my math. So here's the thing. In order for this to be a high-end outlier, okay, so to have a high-end outlier, your score must be above the 71.5. In this case, score must be above a 71.5. Now, I want to go back to looking at our box plot, and I'm going to change some data on here just so you can see what a modified box plot looks like. So here, I'm going to go to Stat. Okay, I'm pressing Enter for edit. And instead of it being, I'm going to go with the numbers 1, 2, 2, 1. And your thoughts are, Miss Yarbrough, that's not even in order. Yeah, I know, I don't care. Calculator put it in order for me, so I ain't worried about it. Okay, so next, I'm going to do it again. I'm going to go, and I haven't done this, so let's see. And I want to see, I'm going to go zoom, stat again. Okay, my numbers are just not big enough to give me an outlier, so you know what? I got you. I'm going to change my values in just a minute. Now, as I play with the numbers, and again, I'm sticking with my L2 because we're going to be using L1. So I'm just have these numbers in here. Now let's see if I'm going to have an outlier that shows. Okay, now remember, outliers can be high end or low end, and I'm just focused on the high end just because that's what I want to do right now. So here, remember, you go zoom, you go to stat, either up or down. I shouldn't have done it that way. Some of you guys, what just happened? Yeah, I shouldn't have gone in that direction. And you see here, you have an outlier, and if you press the trace button, it tells you your minimum, tells you your Q1, tells you your median, tells you your Q3, and then here it tells you your maximum, and at the same time shows you that outlier. And you know it's an outlier because it's a dot all by itself. Okay, so you guys might have to rewind this a couple times so that you can get how to use the calculator. Now, what was the premise of all that? Was to show you what I mean when I am talking about the 5-number summary, low-end outliers, etc. So the next thing I want you guys to do is go to your worksheet right here. I'm at the bottom of page 12. And yes, I love me some McDonald's. But honestly, 39 grams of fat. I feel a heart attack coming, guys. Okay, so what I need you to do is put this in your calculator. And let's remind ourselves of how we do that. Okay? I go to Stat. Here's an edit. I press Enter. And I do want you to put that into your L1. That's what I have mine in, so go ahead and pause and do it. Okay, now the next thing I want to do is let's answer the question. It wants me to calculate and interpret the mean, median, and the IQR. So let's remind ourselves of how we did it a couple of minutes ago. Here, it's in my L1. So I'm going to go Stat, over to Calc, and this is, of course, how I entered it. And at 1 here, first bar is Enter. It's in my L1. So as I move this up a little, I need second and then L1. And then I'm going to, notice to change to L1, and I'm going to press my arrow down to calculate, and I press Enter. So what is it asking me to calculate and interpret the median? Oh, I don't see the median. Just use your arrow. So your median is 26 grams of fat, and they're asking me for my IQR. So I need my Q3 minus my Q1. And as we interpret this, we're saying on average, the median average of the McDonald's hamburgers have 26 grams of fat. Make sure you've written that down. So the average median for the hamburgers have 26 grams of fat. And then as I look at the outlier, I'm sorry, I said the wrong thing because I was looking at that, oopsie. As we look at the IQR, we say here that the sandwiches that they have here vary by 20 grams because the IQR is another way of determining variability. And all I had room for was to write down what the average, the median, that's really important because we've got so many averages going on. The median average. But remember, the IQR is talking about the variability in the sandwiches in terms of the grease content. Okay, now I want you to do number 80. And as you do number 80, just plug it into the calculator. Remember, you are going into where? You are going into your stat, your edit, and how do you delete things? You go up on top where you see that, you press clear and you drop it down. That'll give you the value. That'll clear it for you rather. And then you just enter whatever you want to do, and as you see, it enters down there. Okay, so calculating the mean, that's it. Number 82, cross that out. They're asking you to find the median. We're not finding it by hand. We're just going to find it, and you know you have to use that scroll down button to find it. And now I want you to take a minute and read this, and let's see what happens. Because if you notice, we haven't talked about, well, I'm not telling you what we haven't talked about yet. You'll see in a minute. Okay, so as I look at this particular problem, somebody made a faux pas, meaning somebody screwed up. So here, as I look into they said that they should have put 341 instead of 321. Now you see what your averages were and your median, what your median was also. But now I'm going to go in. I've got it in my L2. It does not matter where you have it. And the 321, I'm going to change to 341 and press enter. Now I want you to tell me what my new mean is and what my new median is. Go for it. Okay, now if you put it in the calculator and when you get to your first vars, okay, you'll notice that you do have a new mean. And your mean is now 298.3. But notice the new median, I said it was new. No, it's not. Your median is the same thing it was before, which takes me to something I mentioned to you earlier. Okay, extreme values or outliers, and I think I need to go back and add extreme values. Extreme values do affect the mean. They are not resistant to the mean. Okay, but extreme values do not affect the median. So that means the median is resistant to outliers and extreme values. Okay, so that's it. You've got your homework, only a few problems. And yes, we will finish working on this tomorrow in class. Bye-bye.